random variable can be split into two. One is discrete, one is continuous. Okay, in discrete we do have probability distribution function. Normally we write it in table. Okay, we call this as PDF, and then we went for CDF, cumulative distribution function, and then all the way we went for expected value, variance, and standard deviation. Now for discrete, all these three parts we have done. Now we are going to go through the same thing with continuous, but it's just for continuous, the probability distribution function for continuous, they have a different name known as probability density function. Still PDF, probability density function, and then cumulative CDF, and then we will learn finally EX, variance X, and standard deviation. Okay, so now let us let us learn this one now, probability density function. Okay, let us look at this example. Example 1. Show that the function is a probability density function. Okay, remember for PDF, for discrete, for you to show it is a probability, for discrete to show is a PDF probability distribution function, you need to prove two things. Okay, let me recall back. In discrete, for you to show it is a discrete probability distribution, okay, for you to show it is a probability distribution, what you have to show, first of all the probability must be in between 0 and 1, and the second thing is the summation of probability is equal to 1. Remember this is what we done in the discrete. Now the same thing goes for something similar to continuous. To show it is a probability density function, first of all, first condition is here. It also has two conditions. The first condition is you have to show that here the probability we have written in terms of fx. The fx is in between 0 and 1, not probability fx, the function itself. And if you, the total probability in continuous, the total probability will be integrated. Hope you guys learn integration in maths. If you integrate fx, you should get 1. Alright, that's the idea. Now looking at example 1 here, my fx is x of 50, but you notice that in discrete they will give you like x equal to 1, 2, 3, 4, 5, something like that, individual number. But in continuous, they will give you in terms of interval. That is the only difference between discrete and continuous. Discrete, all the variables are individual, okay, one by one. And in continuous, they will give you the variable in interval in between two numbers. So it can take all the numbers in between 0 and 10, something like that. So now for me to prove the first condition, let me take x equal to 0, just the end point, x equal to 0. My f0 is 0. If I take x equal to 5, the middle point, this one would be 0.1 if you compute. And if you take x equal to 10, is 0.2. And notice that all are between 0 and 1. The first condition is fulfilled. I give you some time to copy if you want. The second condition, integrate. I suppose you guys are well versed in integration. Constant you can take out. Second condition also fulfilled. So if you want to write this, fx is probability density function of x. Okay. So this would be the second condition. Let us do the question A now. How to answer question A. Normally in discrete, if this kind of function is this kind of question is given, what you have to do, what you will do basically is you will find the x equal to 2. This one don't copy, yeah? 3, you will go 4, and then you will go 5 and pluses, isn't it? But in continuous, we will use the application of integration. We integrate 2 to 5. This would be the answer for A. Okay, this is for A. Now let us go for B. It's the same thing, just a little bit different. This would be the answer for B. Right, this would be example 1. Now we are going for example 2 for continuous random variable. Now normally in discrete, if you have any constant here, h, k, u, a, something like that, remember we use this property. If discrete, we use this property, sum of probability is equal to 1. Same goes here, continuous, the sum is in terms of integration is equal to 1. So we will use in discrete we will use this one, in continuous we will use this one. So find the value of h. Sketch no need, ignore the sketch. Find the value of h from -2 to 2. This one should be 1. H is just a constant number. I can take out h outside. This would be your h. So let us do B now. And I suppose in maths you have learned inequality. This one can be written as like this. So I'm going to split this again, rewriting this in terms of this. This would be the answer for M, 1.59. While copying this, for exercise in class 1, you may try on your own. I can write the answer here. B is 4. This is 16 over 27. You can copy the answer here. Try at home. Later we will check the answer. And exercise in class 2, the answer would be write this one. Exercise in class 1, write the answer so that you can try later. Exercise in class 2, the answer would be 1 over 4. Sketch, no need. And this one 3 over. Right. With that, we will stop here for today's class. Next class, I will start with the cumulative distribution function for continuous random variable CRV. It takes a lot of time for us to understand this CDF for CRV. And I'm still doing some the complete answer for the tutorial. Give me some time. Once I have written, it's a lot, so I need to write and check up the full answer. Hopefully by this week I can finish and upload for you. Alright, with that, I'll see you guys on next Sunday, coming Sunday. Sorry, that's all for today. Thank you. Take care. Bye.
Thank you, Doctor.
Thank you, Doctor.